then y1 and plus or minus, I forgot, y2.
Yeah, this got something to do with that. Y2 minus y1 all over x2 minus x1. So y2 minus y1 all over x2 minus x1. Every single problem we do today, you will use that formula, I promise. You need to know that for your test. Yes. So I would encourage you, every time you work out a problem today, you write down y2 minus y1 over x2 minus x1. Because guess what I'm not giving you on your test next Tuesday?
Y2 minus y1.
I'm not giving you a formula that you learned in 7th or 8th grade. You should know it. And if you write it down every single time you do a problem today, you will write it down about 15, 18 times. Okay? All right, so example. How do we find the slope that passes through these 2 points? Well, the slope is equal to y2 minus y1 over x2 minus x1. We've already written that formula down twice already. So can we label our points? Yeah, so the first point, I'm going to label x1, y1. And the second point, we're going to label x2, y2. It actually doesn't matter which point is x1, y1 and which point is x2, y2. As long as we plug them into the formula correctly, it doesn't matter which point is which. You'll get the same answers. So in this case, y2 is 7, y1 is -5. Be really careful when you subtract, because 7 minus -5 is not 7 minus 5. Those are actually
positive.
different. And then x2 is 16 minus 7. 7 minus -5 actually does end up being 7 plus 5, which is 12. And 16 minus 7 is 9. And we can simplify that. We can divide both of those by 4. I'm sorry, by 3. 12 divided by 3. 12 divided by 3 is 4. And 9 divided by 3 is 3. So we can simplify both of those. All right, so while we're not doing slope, we're doing what we call the average rate of change. And what is the average rate of change? The average rate of change describes the rate at which one quantity is changing with respect to another. So let's talk about snow. Maybe it snowed 2 inches the first hour, and it snowed 6 inches the second hour. How much did it snow on average? So 2 plus 6 is 8. 4. It snowed on average 4 inches per hour. Did it actually snow 4 inches the first hour or the second hour? No, but on average it snowed what? 4 inches per hour. That is this average rate of change. Okay, that is the average rate of change. And how can we think about the average rate of change? The average rate of change is really just the slope of a line. So if you can find the slope of a line, which we just did, which you learned in 7th, 8th grade, you can find the average rate of change. If we know how much it snowed each hour, we can figure out the average that it snowed per hour. Okay? All right, there's 3 different ways that functions can be represented. Functions can be represented graphically, and you can be asked to find the average rate of change given a graph. So in this case, the graph's given, and we want to find the average rate of change on the interval -2 to 3. -2 is going to be our x1 value, and 3 is going to be our x2 value. Again, it doesn't matter which one's x1 and x2. Typically, I just pick the first one to be x1, but that doesn't really matter as long as the y values correspond and we set it up correctly. It's not going to matter. So what's happening here? We're going from x equals -2, which would be down here at -40, to x equals 3, which would be up here at +40. And this idea of average rate of change is really just the slope of the line that connects those 2 points. So if we were to connect these 2 points, the average rate of change is going to be equal to the slope of that line. That's all average rate of change is. In real life, it talks about like how much did it snow per hour on average. mathematically, it's equal to the slope of the line that connects those 2 points. So how do we find the slope of the line? Y2 minus Y1 over X2 minus X1. We've written that formula down 3 times now. You should probably write it down about 18 times today. 16 times, something like that. All right, what is our Y2 and Y1 value? Well, we can look at the graph and figure that out. If X1 is equal to -2, we're looking at this point down here. If the X value is -2, what's the Y value of that point? -40. So Y1 is -40. And if X2 equals 3, what would Y2 equal? We're looking at this point over here now. That would be +40. And now if we just plug the numbers into the formula like we're supposed to, we should be okay. Y2 is 40 minus -40, which is different than just 40 minus 40. So be really, really careful when you subtract a negative number, because it does end up being 80, not 0. Because if you did 40 minus 40, you would just get 0. That's not right. And then the bottom is going to be X2 minus X1, which is 3 minus -2. So we do end up with adding on top. We actually end up adding our bottom as well. And we get 80 divided by 5, which is 16. So maybe you play football, maybe you're out in the yard, you kicked your football or something up in the air, and maybe this graph is the path that your football took or something. What's the 16 represent? The 16 might be something like 16 feet per second. So that ball's changing at a rate of 16 feet per second on average. Does that mean every single second the ball's going up 16 feet? No, that just means on average, that ball is going to go up 16 feet per second on average. But it might not go up 16 feet per second every single second. It might go up like 5 the first second and like 35 the second or whatever the case may be.
I think 16.
80 divided by 5 is 16.
Well, why did you do it like that way then last time you did it where you divided them each time?
Yeah, 4/3 could not, it's not a whole number. 4/3 is not a whole number. But 80 divided by 5 is a whole number. So I just wrote it as a whole number this time.
So you're supposed to do that. You wouldn't divide them like both by like 5.
If you did divide them both by 5, you would get 16/1, which is just 16.
Okay.
So if it's a whole number, we just write the whole number. All right, another graph, same idea. Just to get this idea that we are going from -3 to +3, and this idea of average rate of change is really just the slope of the line that connects those 2 points. So what is the slope of the line that connects those 2 points? We can say X1 is -3, X2 is +3. And if X1 is -3, what would Y1 be? We have to look at the graph to figure that out. That would be this point right here. And that ends up being -40 again. And Y2 would be this one over here on the right, which is actually 50 in this case. So as we're practicing this, I would recommend, again, writing the formula down every single time. One, if you write the formula down, you have something to go by. It's going to be really hard to mess up. Two, you write this down enough, you will eventually know it, and you will not have to even maybe study the night before the test. So Y2 is 50, Y1 is -40. So it's going to be 50 minus -40, which does end up adding. You can just type in the calculator if you want. And then X2 is 3 and X1 is -3. So 3 minus -3 ends up adding as well. So we do end up with 90/6, which is a whole number. 90 divided by 6 is 15. 90 divided by 6 is 15. 90 divided by 6 is 15. We okay with that? Yeah. All right. We could also be given a table because functions can be represented with XY tables, graphs, or equations. So in this case, we're given an XY table. F of X and Y are the same thing. And we're looking for the average rate of change from 5 to 7. Maybe this is snowfall. maybe in the 5th hour, it snowed 9 inches. Maybe in the 7th hour, it snowed 23 inches. Or maybe like that's the snow accumulation. Maybe after 5 hours, 9 inches had accumulated. And after 7 hours, 23 inches had accumulated. So on average, how much did it snow between 5 o'clock and 7 o'clock? We can find that. And this one is probably actually a little bit easier than the other one because they give us a table. If they give us a table, all we got to do is look at the table and find the x values, 5 and 7, and we automatically know what the y values are going to be. So y1 is going to be 9 in this case, and y2 is going to be 23. And if we can find the slope that connects those 2 points, we can determine what the average rate of change is. So we end up with y2 minus y1. I think this is the 5th time today that we wrote this down. 23 is y2, 9 is y1, 7 is x2, and 5 is x1. 23 minus 9 is 14, 7 minus 5 is 2, and 14 divided by 2 is 7. So maybe this data represents how much snowfall is on the ground. So what does the 7 tell me? The 7 tells me that on average, it snowed 7 inches per hour from 5 o'clock to 7 o'clock. Does that mean it snowed 7 inches from 5 o'clock to 6 o'clock? No. It just means on average, it snowed 7 inches from 5 o'clock to 7 o'clock per hour. Per hour. All right, since we're looking at tables, let's drop down and look at the real life example. There is actually, this is actual real life data. We looked at it before when we did quadratic regression on Desmos. And we want to know what is the average rate of change of the number of bald eagle mating pairs from 1963. So 1963 is going to be our X1 to 2000. And 2000 is going to be our X2. Now you see that column in the middle, it says T equals years after 1950. So we could actually, instead of using 1963, we could actually use 13 for X1 and we can use 50 for X2. Does it matter? No, because 50 minus 13 and 2000 minus 63 is the same number. Okay. So what would our Y1 and Y2 be? Looking at the table, that's pretty easy to figure out. Y1 is going to be 417. And y2 is going to be the 6,471. So how do we find the average rate of change? The average rate of change is going to be the slope of the line that connects those 2 points. How do we find the slope of a line? y2 minus y1 all over x2 minus x1. y2 is going to be the 6,471. y1 is going to be the 417. X2, you can use the 50 or the 2000, it doesn't matter which one. And then X1, you can use the 13 or the 1963. And then probably type this one in a calculator. This is real life data, by the way. I didn't make this up. You can Google this. You can find these exact same numbers. This is real life data that some researchers compiled. Secondary data, if we want to go back to Unit 1, start reviewing for our final exam, this would be an example of secondary data because I didn't collect this data. I found it. Somebody else collected it. If you type this in your calculator, you're going to get somewhere around 163.6, which we can round to 164. But what does that tell us? Like, it's good to do math. It's good to do like real life math. But if we can find the 164 and have no idea what it means, we just wasted our time even finding it. So what does the 164 mean in context of this problem? In the context of bald eagle mating pairs? What does that 164 tell me?
164 years.
Not years. Eagles. Eagles. So let's start here. On average. Let's start here. On average. Does this end as an average? So let's specify that is an average. On average. And let's talk about the years. From 1963 to 2000. Comma. On average. From 1963 to 2000. What's happening? The bald eagle population The bald eagle population is
Oh.
it increasing or decreasing? It's changing, right? We know it's changing, but we can be a little more specific and say, yes, it is changing at a rate of, that's really what we're talking about. It's changing at a rate of, but we can also use the word increasing at this point, because we do know that it's increasing. How do I know it's increasing? Well, the table told me it was increasing, and this number is positive. If the slope is positive, it's increasing. Is increasing. So on average, the bald eagle population is increasing. What? It's increasing by 164 mating pairs. Because for some reason this data is talking about pairs of eagles, not just individuals. 164 mating pairs per year. Does that mean that each year from 1963 to 2000, the bald eagle population increased exactly 164 mating pairs each year? No, from 1963 to 1974, it went from 417 to 791, which is not a lot if you think about each year. Because it didn't even go up, well, a little bit more than 300, but almost 11 years. It went up 300 eagle mating pairs over 11 years. So this doesn't tell me what's happening year to year to year. It's saying on average, that's what's happening. On average, 164 mating pairs per year are added to the bald eagle population. And it is an average. When we put the word increasing, we could have used is changing at a rate of 164 mating pairs per year. All right. Now, there's three ways we can represent functions. A graph, a table. Where do we get the graph and the table from? The equation. So now we have two examples given the equation. We're still looking over the interval, -7 to 0. So -7 is going to be x1, 0 is going to be x2. So if x1 equals -7, and if x2 equals 0, how are we going to find y1 and y2? How are we can't just look at the table anymore. We can't just look at the graph anymore. Yeah, we got to plug them into the equation. So to find y1, we're going to plug -7 in for x. And we're going to do that very carefully, especially with this -x² piece. Because the negative is not being squared. So the negative is outside the parentheses. But then whatever number we plug in is inside the parentheses. And then that number is being squared. But the negative on the front is not being squared. So we got to be really careful with that. So we get -7 squared minus 4 times -7 plus 7. And we can type that in the calculator. Maybe we can figure that out without a calculator. Y2, we're going to find Y2 the same way. We're going to plug 0 in, which is x2. Plug x2 in to find y2. And this one's a little bit more time consuming because we do have to find the y values first before we can find the average rate of change. So this first one, we get -49. It ends up being +28 plus 7. -49 plus 35 is -14. And then 0 squared minus 4 times 0, all of that is just 0. And 0 plus 7 is 7. So now we know what y1 and y2 are. We got those by plugging them into the equation. So now we can do the slope formula, which is equivalent to the average rate of change. Y2 minus y1. Y2 is 7 minus -14, all over 0 minus -7. Be really careful when you subtract negative numbers, and we end up with 3. Again, maybe this is, maybe you're growing a garden, and maybe you got some tomato plants. One in particular is growing really well. What might the 3 represent? The 3 might represent, on average, my tomato plant is growing at a rate of 3 inches per day. Does that mean it's going to grow 3 inches every single day? No, one day it might grow 1 inch, and the next day it might grow 5 inches. So over those first 2 days, it grew an average of 3 inches per day. And last but not least, same idea. Second example, We are looking at x1 is equal to -7, x2 is equal to 1. We have to be able to find the y values. So we just plug those in. So y1 is going to be equal to -7 squared plus 7 times -7 plus 6. And y2 is going to equal 1 squared plus 7 times 1 plus 6. And I'm going to stop there for just a second. Let you see if you can finish that. And then I will work it out on the board. I will work it out on the board in just a second. So try that last one there before we go over it. Make sure you can find the y values correctly and do the slope formula correctly.
So this is all that's gonna be on next week's test, this is what was on last week.
Yep, that's it. I'm gonna give you your quiz back tomorrow so you can look at it and see what all you missed and all that good stuff. And we can go over it. Answer any questions you might have about it. All right, this last question, you should have got 6 for y1 and 14 for y2. So y2 minus y1 over x2 minus x1. Y2 is 14, y1 is 6, x2 is 1, minus x1 is -7. So without a calculator, you would end up with 8/8, and 8/8 is 1. So something is changing at a rate of 1 inch per day, 1 foot per second, or something along those lines.